Hello everyone, so now we are going to look the software defined networking, that is SD-WAN. If you remember, when we are discussing the SD-WAN, that time we told in our all router, switches, firewall, all that one is having three plane. One is control plane, one is management plane, one is data plane. Control plane is nothing but wherever we have the controlling protocol like layer 3 protocol or STP, all that thing we will call that is control plane. That is the brain of the router or switch. Management plane means we will use the telnet or SSH SNMP to manage our device, whatever traffic we are sending to manage our device, that is known as management plane. And data plane means our data, whatever our data is forwarding, the main data, that is come under the management plane. So now we need to remember, in our router we are having three plane. Control plane means the brain of the router, data plane means our data is going to forward, management plane means we are going to manage our device by using the telnet, SSH, that one. So these are the three plane. So what we are doing in the SD-WAN, we are removing the brain. We are removing the control plane from the router. We are putting in the controller. Controller is going to control that all the router. Example, this is a PC1, this is a PC2. If some packets are sent, it will come to this router. In the normal scenario, in the traditional network, this router is going to use the CPU and he is going to process, he is going to check this path is good or this path is good. Depending upon which is good, he is going to forward the traffic. Again, this router, example R2, is going to utilize his brain, CPU, and he is going to check here or here where he want to send, he will send. Again, this brain, this R3 is going to think, calculate, look the routing table, everything, and he is going to forward. So this, if any packet is going from here to here, this router using his CPU, this router is using CPU, this router is using CPU, this router is using CPU. All this router is using his CPU and RAM to analyze, to calculate the best route. Okay, example, one packet is going from here to here, from here to here. So how it is going? They are performing the control plane and they are sending the data plane. So they are thinking, they are using their brain. One router is using his brain, this router is using his brain, all the router is using the brain, and depending upon the which path is good, they are sending to that one. So now what we done, we remove the brain from this router, we remove the brain from this router, we remove the brain, we remove the brain, and we put here, this is a one big brain. All these router are with the without brain, without control plane. This we have the SDN controller. This controller is going to control all the router. Whenever the packet is come to this place, this router is going to communicate with the controller. I have this packet, I need to send to here, where shall I send? So this controller is going to give the instruction. Depending upon that instruction, it will go here, because all router is updating his status to the controller. Controller know which path is good. Maybe this router know this one or this one directly connected path is good. Maybe here sometime net go down and come up, but this one he don't know. He know only this route, and he know before this route is working fine, but controller is having all the update. So controller is going to send the information from where this packet need to go. So depending upon that one, this router is going to perform the operation. So that is nothing but controller base. So now they are not going to utilize their brain, they are going to listen to the controller, whatever controller is saying, they are going to forward that one. That is nothing but controller base. So what we done, we remove the brain of all the devices and we put here in the controller, and controller whatever instruction he is giving, they need to follow that instruction. And here we are the network engineer, we are controlling the controller with the help of API, with the help of Python script, with the help of GUI, any GUI application, with the help of any tool, we are controlling the controller, and controller is controlling the all the devices. And if we see, this is the architecture of Cisco software defined network architecture. This is having the, what we can say, this is the devices. Okay, this is our devices having the data plane. This is our controller, and here we are controlling the controller with the help of any application, maybe Python script, maybe any GUI application. With that one we are controlling the controller, and controller is going to control the devices. Okay, so this way we can control. And if you see here, this is another diagram, so you will have more clear idea about this one. So here we have the switch 1, switch 2. They don't have the control plane. Control plane is here in the Cisco DNA center, SDN controller here. So from here they are going to send the instruction. If we want to forward any data from here to here, they will check with the controller. Controller is going to give the instruction. Depending upon that, they are going to forward. And we are going to control the controller by using the any script. Okay, switch are just like a dumb device that only have the data plane, no control plane. As I told here, control plane with the Cisco DNA center or Cisco DNA controller, vManage, or whatever the controller, SDN controller, they are going to monitor that one. And with this one, if you see here, we are using the API. This is our SDN controller. Imagine this is a Cisco DNA center. Here we have the API. We are using the API. That is the API. Like any network engineer using one API. API is nothing but any piece of software. They are using that API to configure, to control the controller. That is known as not-born API. And controller is connecting with any API to control the device. That is known as southbound API. And control plane is with the controller. So just we need to remember the API between the network engineer and the controller, that is known as northbound API. The API between the southbound, that is the controller to the device, is known as southbound API. So what we are saying here, SD-WAN controller, that is SDN controller, has to communicate with our network device in order to program the data plane. This is done through southbound API. This is not a physical interface but a software interface, and that is API, application programming interface. API is a software interface that allows the application to give the access to other application by using the predefined function. So we have the southbound API. Southbound API, we can use the OpenFlow, Cisco OpenFlex, REST API, Netcon, RESTcon, SSH. So this is the southbound interface. We can use any one from that one depending upon our device what they support. In simple, just remember southbound means device to controller, northbound means from network engineer to controller. And northbound, what we are saying, northbound interface is used to access the SDN controller itself. This allows the network administrator or network engineer to access the SDN controller to retrieve the information from it. This could be done through GUI, but it is also offer an API which allow other application to access the SDN controller. We can use this to write the any script, that is maybe we can access with the Python, we can access with the GUI, we can use any third-party application to program the controller. That API is known as northbound API. Okay, so this is the southbound, northbound. And we have the Open Daylight. This is a open standard SDN controller. It is present in the Linux form. And Cisco SDN controller is a API, APIC. That is EPIC. EPIC is nothing but Application Policy Infrastructure Controller. It is designed to manage the data center, but now we have the new one, that is a DNA center. It is designed to manage the enterprise environment like branch and the campus. So Cisco DNA center is nothing but we are using this Cisco DNA center to control all the devices, and we are using this API. So what we can say, Cisco DNA center is nothing but digital network architecture. With this one we can control our devices, and this is like a controller. We can open the controller. Let me show you. I have somewhere login detail. Let me show you. This is a URL. Cisco gave this one. This is a just test account. We will see some operation, but we cannot perform all the operation here because this is only just for the test purpose. So let me open and paste this username. This is open for everyone. Everyone can access, but we will have only read permission, not the write permission. And some options are open for us, some options are not open. They give this for free access just to understand how it works. It is taking some time. We need to put, this is a URL. This is a username and password. So what we can do with this controller, let me show you. Let's go for some theory till it open. It is open, or let me, yeah, it is open. So let me press, this is a username and the password I need to put here. Let me copy the password, Cisco123 : here this is a password, and then press login. So this is the controller. You can control your devices, router, switches, whatever you have. This is your controller, and with this one we can control our devices. This is the sandbox Cisco, just for demo account, just to read how it look. It is loading. Anyhow, we will continue our topic till it open. So what we can say, Cisco DNA Center we use to manage our devices in our organization, in our branches. We can perform the many operation by using the automation. We will use the Cisco DNA controller. Here we can control all the devices. We can monitor the health of the devices. We can perform, if you want to push the configuration, we can push the configuration from Cisco DNA Center. We can configure, we can access the device. No need to log in individually. If you log into Cisco DNA directly, we can access all the devices. Cisco DNA is cloud based also available, or we can use the hardware also. We can install in the Linux server also. This is virtual also available, appliance also available. So we can use this one. Let's see it is open or not. It is loading very slowly. So in the Cisco DNA we have the design first. In design we can select the map where we need to design, like we can select the location and the map, and we can select the router images, and then we have the policy. We can apply the policy whatever we want to do, and the provision we can do. Assurance we have, like health status of the device we can monitor. So we have overall performance we are going to get here, all the device health. And network we can check how many clients are connected, we can check here. Whatever application we can check here, but it is not loading. So here we can, when we click the overall, we will see the tab here. In that one we are going to get the overall information, like CPU status of all the routers and the switches. Let it be, it is this is from Cisco but not working here now. Anyhow, let me show you here. I have here. So what we are saying, Cisco DNA Center, we need to put the username and password. When we put the username password, it will open. And what we are saying, Cisco DNA Center is nothing but digital network architecture center. It can help us to bring all together in a single panel of dashboard. In the single dashboard we can see all the thing. We are going to manage our network by using a graphical and programming interface. It is called Cisco DNA Center. Cisco DNA Center is the application that we can install in our network, or there are options for having the DNA in the cloud. Okay, we can install in our network, or we can use the cloud one. Cisco DNA Center is going to give us the graphical interface and programming interface to design our network, to add the device, configure the device, network monitoring, troubleshooting. So we can do this one. We can configure, we can monitor, we can troubleshoot the network. And Cisco DNA Center focus on the first up their design. First we need to design that. We have the map. In that one we can select the map and locate our building floor, and we can put our device and we can assign the IP address. We can apply the policy. We can also provide the provision. We can also check the assurance also of the devices. And here we have the support also available. Automatically Cisco DNA Center is going to suggest the step to do the troubleshooting, because TAC, there is a technical assistance center is there from Cisco. Whenever we have any issue, we are going to open the ticket from the TAC team. So whatever TAC team is learning, whatever user facing the user experience, whatever how they are solving, they all solution are including in the Cisco DNA Center. Like if you are having one router is using the more CPU, or having issue, so they are going to suggest in the DNS Hunter the solution. We can adopt that solution. Depending upon the tag support, they are going to update that all solution in the Cisco DNS Hunter. Let's see, here it came, or let me go to overall. It is still loading. So with that one, we can what we can say, we can solve the problem also. Means here what I am saying, this is a controller. We are going to control all the devices. We can going to monitor the device. We are going to configure the device. We are going to retrieve the device information, and also we will have the auto suggestion here. If we have any issue, they are going to give the auto suggestion, so we can do the troubleshooting also in our device. So this is a URL and this is a username password. When we log in, we will have the health overview. In this one, we are going to check all the health, like router, core switch, access switch, distribution layer switch, controller. If we are having access point, all the information it will come here. We can click and check which one is having issue, which is working perfectly, or any issue. We will have the alarm here, and there is a suggestion, auto suggestion to do the troubleshooting also. We can click that one. Okay, so here it will show that 100% good. Any critical issue? Nothing. We don't have any critical issue here. And 3 network device we have, 2 site we have connected, like that we will have. So we have the design. We will select the map and we will apply the policy, and then provision, assurance. So with this one, we can manage our network with the help of Cisco DNS Hunter. Let's see, it came here. Yeah, see here, now it came after loading lot of time. So this is our 75% health. Okay, here it is saying the healthy 75%. From total we have 4. This is a core layer. We don't have anything in our network. Router we don't have, switch we don't have. Here we have the distribution layer switch, access layer switch. Controller we have some issue, maybe poor he's giving, wireless controller. And if I double click, it is going to show us what is the issue. We have 1 device, no health data. And if we see memory utilization, we can check here, free memory. We don't have all access, but we can check all the detail about that one. Let me show you here. And access point, we don't have any access point. No device means we don't have the access point. So here we will check all the user also, but here nothing is mentioned. How many users are connected, we can check here also. And if I go to network, it will show us the network report, like it is taking time, like let me load. So it is going to show us the graph about the performance of our network, and we can see the client also, and again it is gone. So with that one, we can have the graph also. We can have the issue. If we have any issue, we can see that one. And we can have the filter here. We can filter, I want to check the performance for last 4 hours, 2 hours, 1 hour, like that we can do. And also we can check the clients also, whoever client is connected. We can check that also, and the application whatever is using. Here we can change 24 hours, everything is good. If you see, it is going 75% healthy. And here we can say distribution layer is good, and here access layer is good. Wireless LAN controller, gray, we don't have any controller, I think, here. So this way it will appear. This is a demo account, that's why we cannot see all here. And if you see, this is a span and leaf architecture, so they have a span here. We can access also from here. We can take the CLI of the device, we can access, we can run the command. Here it is taking long time to load, but in the real scenario, we can easily access the device from here. No need to log in separately. You will have the list of device, just double click. You will have the CLI and access the CLI. Or if you want to push the configuration from here, you can create the template and you can push the configuration also. So this is the, here let me take the CLI. If you see, I can take the CLI. Here I can go enable, and then this is a block here. Let me check the show command, because they will not give all permission. When I write the show run, I wrote what? Show run, I run the show command. Here I write show version. When I write the show version, it is saying it is working. This device is up from the 8 week, 2 days, 55 minutes. So this switch is working from this much time. And here what is the version they are using, we can check also here. This is the latest version 17.3.3. okay, in our organization we are having 16.5 something, but now this is a new version 17.3.3, and they are using, this is a iOS, Cisco iOS XE software. And here you can see this is the MAC address of this device, and this is a motherboard, and you will have the model number. This is a model number. So with this model number you can Google, so you will get the detail of the device. And this is a serial number, and this is the software which they are using, and the image whatever is installed. And we can write show VLAN brief. Maybe we cannot run this command. Let's see, show VLAN brief. So what we can do here, yeah, we have here VLAN. See here, they have two VLAN extra here. Okay, this two VLAN, that is a VLAN 2 and 835. They created two VLAN, but ports are not available. All ports are in the default VLAN. Okay, and only we can run the show command. If I write enable, it is not allowing me to go in the enable mode, and if I go anything, they will not allow me, right? We can run only show command, show IP interface brief. We can check show IP interface brief. They will show us only show command is working here. Yeah, see here they have one loopback 0 they put, and we can write here show IP interface brief. We run show clock, we can say. So to check the time from which location we are accessing this, we can check the time. Time is 1906 and Saturday December 25. So this is giving correct time, and we can perform so many command here. Whatever you want to perform, you can run the show command here. This is IP address we accessing through SSH. Okay, and here performance we can check. And this is this one, this device we accessed just now. If you need detail, you can check here, like from how much time it is up, whatever the memory, CPU, temperature of the device, and the status of that one. Sensor we have, they will show us the sensor information, interface information, whatever interface they have up or down, all that one we can check. Whatever is speed of that interface, half duplex, full duplex, whatever that one. If we have ether channel, we can see ether channel also. So many things we can see. No need to log in individually, directly we can get all the information there only. And if you see, this is a span. So here if I click this one, view 365 degree, so we can view that device also. How it look, it will show us. We have so many options in the Cisco DNA Center. Same like the vManage, here also we have so many option. If you see here, same thing, we can go in the CMD and we can run the command. I think same, it will not allow. Welcome to Cisco DNA Center, they are giving, and show version. I think same device just now what we access. I think same device. Let's see, this is up from how many? No, this is a different device. 7 weeks, 6 days, 17 hours, 15 minutes. This device is up continuously running, and this is a MAC address of the device. This is a spanning tree is going to work depending upon this MAC address. Okay, show spanning tree VLAN 1. Yeah, you can see there is in the spanning tree. Whatever you want to check, you can check here. Okay, this is just a demo account. We don't have the access for more thing, but we will have the idea. Like if you have your switch any issue, you can check the, here you will have the red color, you can click, you can access, you can check here. You will have the alarm here, so you can see, and there will be auto suggestion. They will ask you to perform this operation, that operation. We can reload also the device from here. So we have so many options, and here that is here we can do inventory also. Like example, if you want to check the device software, how many devices we have, what application is running, all everything we can perform from here. So this is what we can say, this is a controller which is used in the branches to control the LAN network. If you want to control the WAN network, then we will use the vManage. vManage, let me show you. vManage, this is a vManage is also we have here. If we go here, vManage, it is Cisco Viptela. Okay, vManage will appear like this. Okay, it's like same like Cisco DNA. If you see, Cisco DNA also look like that. If I go here, we have the vManage. In the vManage, we will have the, this is like same like a Cisco DNA controller, but here we are going to use this in the WAN connectivity. Like whenever we are going to connect to the branches, two branches, we are going to use this Cisco vManage. When you are using in the same inside the organization, then we will use the Cisco DNA Center. Cisco DNA and vManage is both are a controller. Here we are going to control the different branches. Here we are going to control inside the branches. If you see all this here, you can, this is a DNA. So in the DNA center, we have all the, what we can say, capability of the devices, and if green means everything is okay, reachable and manageable. You can check the inventory here. You can check the software images, all inventory you can get, how many devices you have, whatever software they are using, all that thing we can get here. Okay, but this is only the demo account, so we cannot get more information here. Let me refresh. They have some issue in this side. And here also we can have, we can push the configuration, or we can send the configuration to our vManage, the other thing. So this is same like a Cisco DNA controller, but this is used for the managing the branches. What we can say, vManage. Okay, so this is the Cisco DNA. They are using the API. API is nothing but application programming interface. We are using here. If you see this diagram here, imagine this is a Cisco DNA center. Here we are using Nodbon to control this one. That is a Nodbon API. And if you see SD axis is nothing but this is our LAN network. In that one we will have the Cisco DNA center and the Cisco ICE. These both together work to form the internal network. So example, this is our internal network. If you see here, this one, this is our router, switches, everything. And here we have the Cisco DNA controller and Cisco ICE. Cisco ICE is going to check the authentication, authorization and accounting. And this is a Cisco DNA controller. It is going to manage all the devices, and he is going to provide the health status, everything to us. So here what we can say, first of all, let me show you this underlay overlay. Underlay network is a underlying physical network. Physical network means, just in short, underlay network means physical, whatever physical devices what we have. Overlay network is run over the underlay network, and that is a virtual network. Like whenever we are creating the VPN, GRE, that logical thing we are creating, like VLAN, that all known as overlay network. Underlay network is nothing but our physical devices, whatever we have. So what we can say, an underlay network is a underlying the physical network. Physical network, it provide the underlay physical connection, which overlay network is built on the top. Overlay network is a logical topology used to the virtual connect the device. It is built over the physical network. In simple, overlay network means the logical network like VPN, tunnel, whatever we created. Underlay network means our physical devices. So what we can say, the combination of overlay underlay form the SD axis network fabric. And as SD axis is consist of Cisco ICE and Cisco DNA center. So this is inside the organization. If you have organization, inside the organization you will have this thing, like you will have the Cisco DNA, you will have the Cisco ICE, then you will have controller, router, PC, all the devices. So what we can say, this is a underlay, all the physical devices. Then we can say overlay means logical thing like a protocol, and we will have Cisco DNA and we will have the Cisco ICE. They are going to perform that, and we are going to control this all thing by using the GUI. We can access the Cisco DNA or Cisco eyes with the help of GUI, and we can manage that one. Okay, and if you see in simple, Cisco SD Access is nothing but managing our LAN network with the help of Cisco DNA Center and Cisco what we can say Cisco eyes. Then we have the SD-WAN. SD-WAN we already discussed in our starting here. If you see SD-WAN, that is used to manage the wide area network, where we have here, I think, before we discuss here SD-WAN. So same like SD controllers. Here what we have, we will connect the branches, multiple branches with the help of SD-WAN. Before we are using the MPLS, but now with the SD-WAN we can use MPLS, or we can use broadband, we can use fiber, we can use 5G, we can use different services to connect the branches. So SD-WAN, what we can say, SD-WAN is having the software defined WAN connectivity. In SD-WAN we have the 3 controller. Let me show you. Generally whenever we are using SD-WAN solution, we will have the example. I am using SD-WAN. So in the SD-WAN we will have the vManage. This is one controller. We have the vSmart and we have the vBond. So we will have the 3 controller in the SD-WAN. An example, this is your branch 1. You have the branch 2, BR2, BR3. So here you will have the VH. We are calling that is a VH. VH1, that is also a router only. All are like a router. VH2 and VH3. So these all are going to connect with the internet to our all the devices. First they will connect to vBond. vBond is going to verify the authentication of the VH, and if everything is okay, they are going to give the detail about vManage and vSmart, and they are going to disconnect here, and they are going to get the configuration whatever we are going to push, and here they are going to update the routes from the vSmart. Same, this device also going to communicate like this way depending upon the branches. When we take the solution from the Cisco, they are going to get the organization IP, organization name, so that organization name and serial number will be available in the VH, all the VH whatever we are applying. So we need to have the Cisco Smart account to do this one, Cisco Smart account. So from there we can register the devices and we can buy from the Cisco. So now we need to remember this solution, this one, this 3 thing we can have in our own organization, or we can ask only ISP to provide the connectivity. So ISP is going to manage this one. If you don't want to take the headache of the vManage, vSmart or vBond, just you want to connect the branches with the 5G connection, what we will do, we will say service provider, just we need the connectivity through the SD-WAN. So they are going to do everything. This all the devices will be in the service provider. They are going to take care. Just we will have the vManage, one router here. They will connect the internet connection. Example, you will have the 100 Mbps connection from the any ISP. Connect here and connect same internet connection here. Connect internet connection here. And this is a device. They will give you ISP. This is a VH, that is a router. And from here you can connect all your internal network wherever whatever you want to connect. Automatically this will be, they will do the configuration everything. So this will connect to our branches. So we can run our IP phone, we can access the different server from different branches with the help of SD-WAN. Before what we are doing, we are using the virtual lease LAN. We are using the virtual lease LAN MPLS. We are using the MPLS. Now also we can use MPLS. MPLS is going to cost more. If you don't want to put more money for MPLS, you can use the normal internet connection. With the help of internet connection also we can connect the multiple branches by using the SD-WAN solution. Even in the SD-WAN solution, if the organization having more budget, they are using the MPLS connection also. They are using MPLS also. So what we can say, in the SD-WAN we can use MPLS, we can use broadband, we can use the 5G, any connecting media we can use, anything, no issue. So now just remember, SD-WAN is the solution to connect WAN connectivity. In SD-WAN we have 3 controller, vManage, vSmart, vBond, and in the branches we should have the vEdge. vEdge is nothing but a router, and it is available in all the branches. That router need to connect to the internet. So this router is going to get the configuration from the vBond. He's going to authenticate, and he's going to get the configuration from the vManage, and he's going to get all the routes from the vSmart. So this all guys are communicating with the vManage and vSmart. vManage is like same like a Cisco DNS Center. So from here we can control all these devices. Okay, so this one, what we can say, this is our devices. So SD-WAN. So let me